All right, this is 5.4, our properties of logarithms functions, and I am picking up from here, just kind of reminding everybody that our values were log base A2 are 0.301 and log base A3 is going to be 0.477. And we've done A and B. We're going to move on to part C. All right. And if you think about log base A of 81, we have a base of, we have a exponential thing going on there, that 3 is the base of that exponent, or of that value. We know what log base A3 is, and then we have it to the 4th power, would give us 81. So that becomes 4 log base A3, and then we're going to multiply 4 times that 0.477, and that's going to give us 1.908. All right, log base A, 1/4. There's a couple ways of approaching this, and I will address both. One of them is here, and then I'll do one by hand up above it. So we're going to pull it apart, so it's log base A1 minus log base A4. And that's going to, log base A1, remember that's always, always, always. Anytime you have a 1 in that place in the log, you're going to have a 0 as the exponent. Okay, so that one's an easy one. Now you're going to have log base A2 squared for that 4. Right? We have our choice of 2 and 3. We don't have any other options. So in this case, it's the 2 squared. And then we're going to pull that 2 down in front. So it becomes a negative 2, right? This is negative. This negative comes here, right? Negative 2 log base A 2. And then that negative 2 times the 3.01 is going to give us a negative 0.602. All right. Actually, let me go back. I want to do that second option. The other way you could have approached this, and this is not wrong, okay? It will get you to the exact same place, but it kind of, it depends on how you see this. Whether you see it as, oh, this is a fraction, I could take it apart, or you could see it as 1/2 squared, right? And so we would wind up with this, the 1/2 squared is the same as a 1/4. You'd have the log base A 1/2, right? So log base A are 1/2, and if actually, I should probably have brought this down in front to start with. So I've got my 1/2. When I bring my denominator, I need a 2 here, 2 or a 3. So I'm going to bring this denominator up, and that's going to become a 2, and it's going to be a negative 2. And then here, I'm going to take this negative 2, log base A, 2. And if you take a look, this is exactly the same solution as we have here. So either way, whichever way you approached it, right, you would have had the same result. So that's another, like I say, another way of thinking about it. There's more than one way to approach problems. Don't be afraid that if you're kind of stuck with one, go back and maybe play with it a little bit, see if there's another way that you can approach it that it makes more sense and makes your life easier. All right, let's go ahead and take care of E. Now this is a log base A 5. And the question is, can we do anything with this? We have a log base 2, or log base A 2, and we know about log base A 3. Can we do anything with this log base 5? The answer is no, we can't. Because we don't know, we don't have a multiplication problem or a division problem happening so that we can address the exponent. If we were told what log base A5 was, then we could. But as it stands right now, with the information we have, we can't do anything with it other than leave it as log base A5. All right, so this one is log base A3 over log base A2. Now I want to point out something really, really big. This is not the same thing as log base A 3 over 2. This is not the same thing. They are not the same. What's happening here is we have a change of base happening, okay? Because we have the log base A on top and then the log base A in the denominator as well. So this is literally, we're just going to take the values for it. So our log base A3 becomes our 4.77, and our log base A2 becomes the 0.301. All right, so that's going to approximate 1.585. All right, so we've kind of already addressed this piece, but I want to be real specific here. If I have something that's log base A, and A is my value and is raised to some other value, to some exponent, that exponent is the only thing that's left, because this is the same as saying x times 1, right? This log base A is 1. And as long as you remember that, that makes the x be the only thing that's happening, right? So let's go take a look here. We're going to go ahead and address this. Our log base A to the 8th. Okay, we're going to bring that 8 down in front, right? And then we're going to multiply that 8 times this value. Well, log base A is a 1. So it's an 8. That's it. We're done. Similarly, our ln e to the negative t. Remember, ln is log of e. All right. So then I'm going to take this negative t and pull it down in front, and then the ln and the e cancel each other out. It becomes a 1. So in that case, we are again going to have just something as straightforward as negative t. All right, something to keep in mind when we are dealing with log and it's not a specified base, it's a log base 10. We understand that to be true, even though we may not spell it out completely. So what's going to happen here is a couple things. First of all, we're going to rewrite this piece as log base 10, and then remember, this exponent is going to come down in front, right? So I'm going to just do that, and I'm going to put my little 10 here, right? So sometimes it helps to kind of think that through ahead of time and then take the baby steps along the way. All right, so here's my log base 10 raised to the 3k. There's my log base 10 raised to the 3k. And then the log base 10 is going to become a 1. And the only thing that's still left is that 3k that was an exponent that we brought down in front. All right, so this is effectively the same thing, okay? So here we're saying we've had our thing where we're saying log base A, all right, and then we say it's a to the something. This is the same as saying kind of the inverse of that. It's sort of our, if we have log base A to the x, well, then if we have log base A, this a and this a, again, that log base a is going to cancel out to be a 1, and this is going to come down in front just like it would any other way. So this becomes our x. Alright, so here we're going to do the same process that we've been doing. I'm going to take a look at my 4 log base 4k. Remember that 4 and the log base 4 is going to cancel out. So it's just k. Here I have e to the ln 5. Well, the e and the ln, those are going to cancel out. So I have a 5 as my result. And then I have a 10 log base 7 t. And so stop and think about that for a second. It's a little tricky because at first it's not clear whether they're talking about log base 7 or whether it's log base 10. And in this case it's a log base 10. So you have 10 log base 10, 7t. And so we pull that, finish filling everything in there, and so that becomes a 7t. All right, we're done.